Dear friends, welcome to the another chapter. Today we are to talk about vibrations and we are solving a first problem related to vibration. Let us see what is given data for the problem. A shaft of 85 millimeter diameter and 900 millimeter length has one of its ends fixed and the other end carries a disc of mass 500 kg. The Young's modulus of elasticity of the material of the shaft is 196.5 kN per millimeter square. Determine the frequency of longitudinal and transverse vibration. Dear friends, here for given data, we have to find out two frequencies, longitudinal frequency and transverse frequency. So here there becomes two cases to be solved. Considering first what is the information given, diameter T, that is given 85 millimeter, means it is 0.085 meter. Length of the shaft is given 900 millimeter, that is 0.9 meter. Modulus of elasticity, that is Young's modulus E, is equal to 196.5 kilonewton per millimeter square. So it can be written as 196,500 into 10 raised to 6 Newton per meter square. And mass of the disc is given is 500 kilogram. Hence the weight will become mass into gravitational acceleration mg, that is equal to 500 into 9.81 gives us 4905 Newton. Now first let us consider case 1 for transverse vibrations. The arrangement is like a cantilever beam as shown in figure. So once we are to find out the frequency of transverse vibration, the arrangement of this given system will be somewhat like this. Here the shaft diameter is 0.085 meter, length is 0.9 meter and weight acting is 4905 Newton. Now we know for this particular case of cantilever type of condition, the deflection in the shaft delta is given by WL cube upon 3EI, where I is nothing but moment of inertia of this shaft. So that is given by pi by 64 into d raised to 4. So delta can be calculated using this formula, and substituting the data, we found delta is equal to W, that is 4905 this Newton, into L raised to 3, L is 0.9 meter, so 0.9 raised to 3 divided by 3 into E, that is we have denoted in data, that is 196,500 into 10 raised to 6 Newton per meter square, that is here, into I, that is pi by 64 into d raised to 4, that is 0.085 raised to 4, it is this diameter. On calculation we found that delta is equal to 0.002367 meter. Now we know that the natural frequency of transverse vibration is given by Fn is equal to 1 upon 2pi under root g upon delta. G is gravitational acceleration and delta we have calculated. So substituting this value, we found is equal to 1 upon 2pi under root 9.81 divided by 0.002367, and hence on calculation we have the natural frequency of the given system is 10.25 Hertz. Friends, now let us consider the second case it is for longitudinal vibration of the arrangement that is shown in figure. It is like this. Here again the dimensions are same. The diameter is 0.085 meter, length is 0.9 meter, and the weight acting is 4905 Newton. So we know that in this case the deflection because of this weight acting, delta is equal to W into L upon A into E, where W is the weight acting, that is 4905 Newton, L is the length, it is 0.9 meter, A is the cross-sectional area of this road, so it is pi by 4 to d square, and d is 0.085 meter, that is here, into E, that value is known to us, 196,500 into 10 raised to 6. So on calculation we found that is equal to delta is equal to 3.959 into 10 raised to minus 6 meter. Now we know the natural frequency of longitudinal vibration is given by the relation Fn is equal to 1 upon 2 pi under root g upon delta. Substituting the value of g and delta, that is 9.81 g value of g and 3.959 into 10 raised to minus 6, which we have just calculated, and on calculation we found the frequency is equal to 250.53 Hertz. So friends, we can conclude at the end that natural frequency of transverse vibration for the given system is 10.25 Hertz and natural frequency of longitudinal vibration is 250.53 Hertz for the given case. Thank you very much friends. I hope you understand the entire process. आपको अगर कोई प्रॉब्लम है लैंग्वेज में या समझने में तो आप मुझे कमेंट सेक्शन में लिख सकते हो, सो आई कैन एक्सप्लेन यू इन मोर डिटेल वे. अगर ऐसे ही प्रॉब्लम आप कंटिन्यूअस देखना चाहते हो, समझना चाहते हो, तो ये चैनल को सब्सक्राइब कर दीजिए और अपने दोस्त को भी बताइए, शेयर कीजिएगा. थैंक यू वेरी मच.